Hello everybody. Today we are going to cover Python package called Numpy, also known as numerical Python. It is a widely used package for scientific computing and data analysis, and it's quite useful for fast and efficient storage of multi-dimensional data. It has all the various functions to manipulate, import, export, and analyze data. So let's get started. So as I mentioned before, Numpy is a very useful tool when it comes to data analysis. It provides you a bunch of functionalities to make your lives much easier. So let's go over a few of those functionalities. So you can use Numpy to manipulate your data using array operations like addition, subtraction, multiplication, exponentiation, etc. You can use it to sort your array into ascending or descending order, get the unique elements of your array, or even perform set operations like unions or intersection. You can use Numpy to calculate descriptive statistics like mean, mode, median, or standard deviation to summarize and describe your data. You can use it to read, merge, and join different data sets. And you can use it to filter your data using Boolean logic instead of writing tedious for loops. So you can think of Numpy array as a table or a grid of values where each value belongs to the same data type. So for example, a NumPy array containing strings should only contain strings, or a NumPy array containing floats should only contain floats as its elements. So it's a little bit different than lists where you could have different data types in the same list. However, the indexing of the NumPy array works exactly like that of lists. So a NumPy array has four attributes. dtype, which is the type of the data in the array, whether it's a string or it's an integer. Endin, which is the number of dimensions. Shape, which is the size of each dimension of the array. And the size, which is the total number of elements in the array. So in Python, there are a bunch of ways to create a new NumPy array. So for example, you could use other data structures like lists or tuples or dictionaries to create your NumPy array. You can use NumPy's own functions like arrange or linspace to create a new NumPy array, or you can create an array by reading data from files directly. So here's an example on how to call the NumPy package in Python and how to use it to convert a list into a NumPy array. So first of all, to call any package in Python, you need to use the keyword import followed by the name of the package, and then you can give it a dummy name to refer to the package as. In this case, we refer to NumPy as np. So anytime I want to call a function from NumPy, I'm going to use the keyword np dot the name of the function that I want to call. So here I have a list with integers from 1 to 6, and to convert it into a NumPy array, I'll use the function np.array and give it the name of my variable, which is my list. Now let's print out some of the attributes of the array. So to get the shape of the array, I'm going to use the name of my variable ar1.shape, which is just a tuple with 6 elements. The object is just a NumPy array, and the contents of the array are just integers. The total number of elements in the array are just 6, and the dimension is just 1. So here is another example on how to initialize a NumPy array using its own function, arrange. So arrange takes 3 arguments: start, which is the starting value; stop, which is the ending value plus 1; and the step size, which is the increment between the start and the stop value minus 1. So as you can see, the result of using the np.arrange function from 0 to 5 with a step size of 1 gives us an array of 0, 1, 2, 3, 4. So far, we've only seen one-dimensional array, but NumPy allows us to make n-dimensional array. So for example, to create a 2-dimensional array, you can use a list of lists, and you can use the function np.array to create a 2-dimensional array with elements 1, 2, 3, 4, 5, 6. So now that we know how to initialize a NumPy array, let's have a look on how to access the elements of the array. Now, as I mentioned before, NumPy array indexing is similar to that of a list. However, unlike lists, it does support multidimensional indexing for multidimensional array. In this case, we have a 2-dimensional array. And if I want to access, for example, the first row, second column of my array, I can access it using the square brackets, 0, which refers to my first row, and 1, which refers to my second column. Similarly, I can print a whole row using the square brackets, 0, which refers to the first row, and colon, which refers to all the elements of that row. And you can use the same logic to print a column or multiple columns at the same time. So here's another way of how to initialize a NumPy array using some of the other functions in NumPy. So for example, if I want to create a NumPy array of size 3 by 3 with all zeros, I can create it using the function np.zeros in parentheses give the shape of the array. Similarly, if I want to create an array of all ones, I can create it using the function np.ones and in parentheses give the shape of the array. So here's an example on how to modify the values of your NumPy array. So my initial array had the values 1, 2, 3, 4, 5, 6. And let's say I wanted to change the value 1 to -100 and 4 to 10. To do that, all I need to do is access the element that I want to change, in this case 0, 0, which corresponds to 1, and 1, 0, which corresponds to 4, and assign it the new desired values. So here's an example on how to perform array operations on NumPy array. So you can perform addition, subtraction, multiplication, square, whatever you want on your NumPy arrays. All you need to be careful about is the arrays should be of the same size. So here is a small list of functions that you can use to get some statistics on your data and perform some data analysis. So you can use np.sum function to compute the sum of the values of an array. Similarly, you can use the mean, the max, and the min function to calculate the mean of your array, the max and the minimum values in your array. And you can use the argmax and argmin function to compute the index of the maximum and the minimum values of an array. Now, NumPy has way more functions than the one listed here, and you should check them out in their documentation. Probably any mathematical function that you can think of already exists in this package. So here's an example on how to use the functions we just learned about in NumPy. So assume you have an array of size 3 by 3 and you wanted to calculate the sum of all the elements of the array. You can use the np.sum function and in the parentheses give the variable name, which is x. You can calculate the mean in a similar fashion. Now let's say you wanted to calculate the sum of the array but along the rows. To do that, you can give another argument in the parentheses called axis and you can set it to 1, which represents rows. Similarly, you can give the axis equal to 0 to represent columns. So in this example, we are going to go through some of the other functions that the NumPy package provides that are quite useful. So for example, if you want to reshape an array, you can use the reshape function to do so. As long as the total number of elements before and after reshaping are equal, you wouldn't run into any errors. Similarly, you can get the transpose of a matrix using the dot capital T. Now the transpose of a matrix is just that the rows become the columns and the columns become the row. You can perform matrix multiplication using the dot function. Now just be careful about matrix multiplication. The number of columns on your first array should be equal to the number of rows of your second array. Otherwise, you might run into size mismatch errors. So in this example, there are some other NumPy functions that are quite useful that we haven't seen so far. Now assume you have an array which has a bunch of duplicates, and let's say you want to sort this array. To sort this array, you can use the np.sort function and it will give you a sorted version of the array. Now, if you want to calculate the unique values in the array, you can just use the np.unique function and it will give you the unique elements of the array. Now, let's say I want to filter my array and I only want the values that are greater than 5. To do that, I can use the condition x greater than 5 and it will give me a Boolean array with the values true and false, where it's false when the value is less than 5 and true when the value is greater than 5. And you can use this Boolean array to actually access the elements that are greater than 5 by putting the Boolean array inside the square brackets. And you can even find the elements that are greater than 5 using the np.where functions. And that brings us to the end of the NumPy tutorial. I hope you guys enjoyed it. And if you have any further questions, please feel free to contact me or Matt or any other person in the Launchpad team. We'll be more than happy to help you out.